Alright, so this will be the code walkthrough for the first and second University of Cambridge Baking Pi Raspberry Pi tutorials. Just get right to it, I guess. So this first section here, these are just assembler instructions, pretty much telling it what's what. For example, we have the initialization section. That's going to tell it where to the assembler where to start the code. Otherwise, it'll pick the first file alphabetically and assume that's the beginning of the code. Not actually something we have to worry about here since we only have one file, but regardless, it's good to have it to get into, I suppose. Alright, so we have our start here, and here begin the actual instructions, which you can see by these little mnemonic codes, they're called. And the first one is load register R0 with this value. This is just an address. It doesn't really mean anything to us except for that it is the address of the GPIO controller. So we'll be needing that to turn the ACT LED on and off. First section right here, this is important as it readies the GPIO 16 or the ACT LED for output. So first instruction, we're just gonna load into R1 the value 1. Now this instruction is kind of tricky. You need to know a little bit about the hardware and how it's all laid out in the Raspberry Pi. So there are 54 GPIO pins in total. Each is represented by 4 bytes. So bytes 1 through 4 or 0 through 3 represent 1 through 10, and so on. So since we're dealing and within each of those 4 bytes there are 3 bits that represent each pin. So so we're dealing with registers 10 through 19. In order to get to the 6th GPIO, we need to move over 18 times, because 6 times 3, 6 hops, 3 bits per hop. This part is we're loading into register 1 the GPIO controller address plus 4. This is like I said, each 10 is represented by 4 bytes, and we need to move over those 4 bytes. So we're dealing with registers 10 through we're dealing with GPIO pins, 10 through 19 instead of 1 through 9 or 0 through 9. This next section is kind of the most important, as it actually turns on the LED, and we do it in a funny way by actually turning off the GPIO pin. By default, for some reason, all the GPIO pins are set to on, and turning them off will actually turn on the LED, which we're trying to do. So we're just going to load into R1, and we need to shift it over 16 times. This is because in order to affect the GPIO 16, we need a number that has a 1 in the 16th place. So no easier way to do that than just shifting a 1 over 16 times. And this is the line where writing to R1 the value of the GPIO controller address plus 40. This is the address we need to write to turn the pin off, which will in effect turn the LED on. So after that, these are just labels for the loop. Really all this is going to do is just run over this code constantly, and we'll always have the LED on. And since it's short, I'm just going to go over to grab here. This is the second tutorial, the code from the second tutorial. It's very similar. Really, the only change is this block of code right here, and this is different as well. So start with this. First line, we're just going to load a very large number into register 2, 3F0000. Not totally sure what that is in binary or decimal, but suffice to say it's big. Here's the label for starting our loop, and this is the code we're just going to loop over 3F0000 times. We're going to subtract from that number 1 and compare it to 0. If this comparison is not equal, branch if not equal, back up to here. So this is going to loop 3F000 times, and that's after turning the LED on. And then after that, we have to write to the GPIO controller address plus 28, which will effectively turn the GPIO pin on. Well, it'll turn the GPIO pin on, turn the act LED off. And after that, we cause another delay with the exact same code. Then we hit the loop, and we go back up to the beginning of the loop here, and do it all over again. Turn the LED on, delay, turn the LED off, delay. So that is it, and you can see this running in the same post. So thank you for watching.